Hi, so in this video we'll talk about Saccharomyces cerevisiae. I want to talk about this yeast because we can find it everywhere in our modern world nowadays. That's the yeast that you find in nutritional yeast. That's also the yeast that you find in some probiotics like Saccharomyces Boulardii. And it can be found in most modern processed foods. So it can cause issues, and that's why I wanted to talk about it today, because many people don't know about this yeast. So that's what we will talk about today. Okay, so I used these studies and these articles to make this video, so I put the links in the description box under this video if you want to go read these studies yourself. So what is Saccharomyces cerevisiae? So as I said, it's a yeast, and the name comes from the Greek saccharro, that means sugar, and myces, that means fungi. So it's a fungi that feeds off sugar. And cerevisiae comes from the Latin cerevisia, that means beer, because since the antiquity, this yeast was used to make fermented foods and drinks, alcoholic drinks like beer or wine. So it's a wild yeast that is naturally present on the surface of plants and in particular on the skin of fruits. It has been used since the dawn of time by humans for fermentation of food products and drinks, as I was saying. So under aerobic conditions, it means that there is oxygen. So it converts glucose into CO2 and water. And under anaerobic conditions, it produces ethanol, that is alcohol. That's how we make alcohol drinks like beer, wine, and other alcohols. Pasteur, in the middle of the 19th century, demonstrated the role of yeast in the fermentation process. So where can we find this yeast? So as I said, nowadays we find it absolutely everywhere, in our modern food, in our drinks, everywhere. So that started mainly from the middle of the 19th century, when bakers, in order to be able to industrialize their production, needed a faster and more reliable fermentation process than the traditional sourdough. So they gradually gave up sourdough for yeast. So it started in the middle of the 19th century, but even more from the beginning of the 20th century. So before that, these fermented foods and drinks were made with wild yeast. Okay, so that's the main difference. And then they isolated Saccharomyces cerevisiae, this yeast, and they used only that yeast, okay, instead of the wild ones that had lots of different strains of yeast, and they also had bacteria. So there was like a symbiosis between lots of yeast, lots of different bacteria that they used to ferment the foods and the drinks. But now it's only one yeast, and that's the problem, but I will detail that later. So where do we find that yeast? We find it in bread and pastries, cakes and pizza, actually in any food made from dough, because to make the dough rise, they use the yeast. And because, as I said, the yeast, when it starts eating sugar, it will produce CO2, carbon dioxide, that makes the dough rise. Okay, so that's the use of this yeast in our food. It's to make the dough rise. So we can find this yeast in baker's yeast. And baker's yeast is Saccharomyces cerevisiae. That's it. There's no other strains in baker's yeast. It is also used to make all alcohols you can find: wine, beer, cider, rum, vodka, etc. You can find that yeast as probiotics, like Saccharomyces Boulardii. I will talk about it in a little later. And also you have you can find probiotics that have just Saccharomyces cerevisiae yeast. You will find that yeast in vegan cheese, what the vegan use to replace real cheese, because the yeast has like a cheesy flavor. You will find it in products like Vegemite, that is something they eat on a regular basis in New Zealand and Australia. And this yeast is also used a lot in lots of different studies, in laboratories to study lots of different things. And also this yeast is used to make hepatitis B vaccines, and it is used to make interferons to treat some types of cancers. So now, what is the difference between sourdough bread and regular bread? Okay, so sourdough, I will explain how you make sourdough. To make sourdough, you take flour and you put water until you make a paste, and you stir, and you let it sit somewhere in your kitchen at room temperature. And then every day you add a little bit of flour, a little bit of water, you stir, and you let it sit. And after a few days, the bacteria and yeasts that are naturally on and in the flour, and also that are naturally in the air, they start to develop, to grow on that mix, and they start eating the carbohydrates in the flour. So little by little, they multiply, they grow, and that's how you make sourdough, the starter. Okay, so again, sourdough is made from the natural wild yeast and bacteria that are in the flour and in the air. Okay, and then to make bread, people who make sourdough bread, they take this sourdough starter, they mix it with flour and water, they mix it really well, and then it makes the dough, and they let the dough sit somewhere, and they let it rise for a few hours, because as we said, yeast will produce carbon dioxide when they eat the sugar from the dough, and that's why it makes it rise. Okay, so this is how is made sourdough starter and how is made sourdough bread. Because sourdough is made of yeast and bacteria, the main difference compared with regular bread made only from yeast, the main difference with sourdough bread is that the bacteria in the mix, they also feed off sugars, but also they feed from other micronutrients like proteins. So the bacteria, what they do, they eat the sugar, they eat the proteins like gluten, and they also deactivate the anti-nutrients. These things, only the bacteria can do it. The yeast don't do that. As I said, the yeast, the only thing they do, they eat the sugar and they produce carbon dioxide. And when there is no oxygen, they also produce alcohol. But that's not really what happens in bread. Even if they produce a little bit of alcohol anyway, when you cook the bread, the alcohol evaporates. So anyway, in bread, yeast are only used to make the dough rise, whereas bacteria in the sourdough starter, they will break down gluten and deactivate the anti-nutrients. And also, when bacteria eat, they produce acids, okay, like lactic acid. And that's why when you eat sourdough bread, it's always a little bit sour. That's because of the bacteria. And it's a good sign if it's a little bit sour. It means that it was made with real sourdough. And it means that this type of bread will be much easier for you to digest. For people who have gluten intolerance, for example, they will have, for them it will be much easier to eat sourdough bread compared to regular bread. Okay, and generally sourdough bread is much more digestible than regular bread. Okay, so some bakers who make sourdough bread, they will let the dough ferment for 5 hours. Other bakers will let it ferment for 8 hours. Other bakers for 6 or 7 hours. Some bakers will let it ferment in the fridge. Some bakers will let it ferment at room temperature. So the best type of sourdough bread you can find will be sourdough bread that was fermented the longest time. Like, it's better to choose sourdough bread that was fermented 8 hours compared to 5 or 6 hours, because the longer it is fermented, the more the bacteria break down the gluten and the anti-nutrients. And it's better to choose sourdough bread that was, fermented at room temperature, because at room temperature, the bacteria and yeast are really alive and working a lot. Whereas if they fermented it in the fridge, the fermentation will be much slower, so they won't really break down all the anti-nutrients and the gluten as much as what they would do at room temperature. So what I mean here is, if you know different places where they make sourdough bread, maybe it would be a good idea to ask them how they make their sourdough bread, how long is the fermentation, and so on. And then you choose the best one, the one that fermented the longer, the dough with the sourdough starter, and the one that fermented it at room temperature compared to fridge to in the fridge. Okay, so what is regular bread? So regular bread, they only use one yeast, that is Saccharomyces cerevisiae. So let's say we are in one of these bakeries that make regular bread. So what they do, they take flour, they take water, and they start making the dough. And when the dough is ready, what they do, they don't add sourdough starter, they add yeasts. They add Saccharomyces Cerevisiae yeast. They mix it with the dough, they let it sit somewhere at room temperature so that they let the dough rise under the fermentation of the yeast. So what it will do when I do it this way, so Saccharomyces cerevisiae is quicker to make the dough rise. Okay, so instead of having to wait several hours for the dough to rise, they will wait maybe I'm not sure about the time they use for when they use this yeast, but the fermentation will be much faster. And also, as I said, the only thing that the yeast does is that they produce carbon dioxide. So the only thing it does, it make the dough rise. That's all. They don't do anything else. They won't break down gluten. They won't deactivate anti-nutrients. And because there is no bacteria in the fermentation process, there won't be any sour taste of the bread. Okay, so that's it. That's what they do when they make regular bread, and that's why it's much less digestible compared to sourdough bread. Okay, regarding alcohol, when they make alcohol, nowadays they use the Saccharomyces cerevisiae yeast, whereas since the dawn of time, when humans made alcohol, they always used wild yeasts. So using lab-grown yeast, that is Saccharomyces cerevisiae, that they use nowadays, this is something totally modern, that is very new in human history. So here I've put on this slide an extract of an article. The link again is in the beginning of the video. I've put it in the first slide. But here they say that until the 1970s, almost all fermentations were what is known as wild ferments. Okay, and then after the 1970s, like 99.9% of the alcohols you will find in the supermarkets or even in your health food stores are made with lab-grown yeasts. Okay, so why did they stop using wild yeasts? And why did they start using lab-grown yeast? Well, that's because lab-grown yeast, Saccharomyces cerevisiae, is much tougher, and it is much easier to control the fermentation with that yeast because it's always the same yeast compared to something wild. Because when it's wild, there's not only one type of yeast. There are many types of different yeast, and there is bacteria. So because it's more wild, because it's more natural, because it's more diverse, it will make alcohols that can vary. Like one batch will have that taste, the other batch will have a slightly different taste. And what they want nowadays in industrial food processes and industrial alcohol and so on, they want all of their products to have the same taste, the same look, the same color, the same odor, etc. Okay, so that's why they use artificial yeast now, because it's much easier to have the same products over and over again compared to wild yeast. And also lab-grown yeasts, they are much more resistant to different types of stress. They can survive high temperatures compared to wild yeast that would die above 35 degrees Celsius. The lab-grown yeast, they can tolerate much more alcohol than wild yeast, and because of that, they can make, winemakers, for example, they will make wines that have a higher percentage of alcohol. They can do that only with the lab grown yeast, not with the wild yeast. Because here, as it says in this article, when you use wild yeast, the alcohol levels reach only 6%. And if you want to reach an alcohol level above like 10, 12, 14%, that's what we have now when we buy modern wines. The alcohol level is usually quite high compared to old wines, because like a century ago, red wine, like all types of wines, didn't have as much alcohol as the modern wines now. That's because wild yeast cannot survive with a high level of alcohol. Okay, so here taking the example of wine, but the process is similar to all to other types of alcohols. But here I will keep with the stay with the example of wines. So how they make wine? First they harvest the grapes, and then they crush them, and then they put them in tanks, and then they let it sit there for a few days so they let the fermentation process start. Okay, so when they used wild yeast, that's what they would do. They harvest the grapes, they crush it, and they let it sit for several days, and they let the wild yeasts that are naturally present on the surface of the grapes, so they let the wild yeast ferment. Okay, so now what they do, when they arrive to this process, after they crush the grapes, they put the crushed grapes in a vat, and at that point now, what they do, they put sulfur dioxide to kill the natural yeasts and bacteria that are naturally on the skins of the grapes. And then they add lab-grown yeasts, Saccharomyces cerevisiae. And that will be Saccharomyces cerevisiae that will ferment, that will make this fermentation process. Okay, so that's the main difference. That's the big difference. Okay, so I recommend that you buy alcohol that is wine or beer or any other type of alcohol that were made with wild yeast. Why? Because I always say in my videos that if you want a healthy gut, you need to have a jungle in your gut. You shouldn't have a monocrop. Okay, that means that in your gut, to have a healthy gut microbiome, you need hundreds and thousands of different strains of bacteria and different strains of yeasts. You will have dysbiosis, you will have a gut infection when one type of yeast or one type of bacteria overgrow and take all the space in your gut compared to the other types of yeast and bacteria. That's how it happens. That's what is a gut infection. That's when one strain, or maybe two or three, but that's when some strains take over and invade like your gut. Okay, so a healthy gut is when all the yeast and bacteria work together in symbiosis, and that's when there are a lot of different types of bacteria and yeast. Okay, so if you drink every day wine that was made with artificial yeast, with one type of yeast that is Saccharomyces cerevisiae, if you drink this type of wine every day, and you also drink some beers every day made with that yeast, and you also eat bread that is made with that yeast, that is not sourdough, day after day after day, you bring more and more and more of that only yeast. And that's how it will create an imbalance in your gut, in your digestive system. And that's how you can have dysbiosis. So dysbiosis, like candida infection or Saccharomyces cerevisiae infection, they don't happen just because you get a lot of them in their yeast form. This will prepare the terrain to be bad, and you will have the infection when something in particular happens that stops your immune system from functioning. And it will be chemical products like antibiotics. Okay, so let's say every day you drink beer and wine made with Saccharomyces cerevisiae, and you eat bread made with Saccharomyces cerevisiae. Now, day after day, you build up in your gut lots of Saccharomyces cerevisiae yeasts. But at this point, they won't cause issues, really. They won't cause symptoms because they are in their non-pathogenic form. Okay, but then let's say one day you take a course of antibiotics that completely mess up your gut microbiome, and because you had a huge amount of Saccharomyces cerevisiae yeast in your gut, then when you take the antibiotics, it will kill the bacteria. And when the bacteria are gone, there's nothing that can keep Saccharomyces cerevisiae in check. And then you will have an overgrowth of Saccharomyces cerevisiae. You will have symptoms. You will get sick. You will have gut infection. So this can happen with any type of yeast. Usually we hear more about Candida albicans because this will happen most of the time with this Candida albicans yeast compared to other types of yeast. But it can happen with Saccharomyces cerevisiae. Okay, I hope I was clear and it was not too confusing. But yeah, so it is possible to find wines made with wild yeast. I'm not sure about the other types of alcohol, but I know wine, yes, you can find wineries where they use only wild yeast. And so I suggest that you make your research. And yeah, if you want to drink wine, always choose wild yeast wines because they will have like a proper balance between different yeasts and bacteria in the wine. So there will be good probiotic drinks. They won't cause issues, and it will be the opposite. They will help your gut microbiome. Okay. So talking about the gut microbiome, so Saccharomyces cerevisiae is naturally in our gut microbiome. It is found on the skin, in the mouth, in the oropharynx, on the lining of the intestine, and in the vagina of healthy humans. Okay, some specialists consider it to be part of the normal microbiota of the digestive system, while others believe that it cannot be considered part of the natural commensal microbiota of humans since it comes from food. And actually, these are the ones who these people are right, because indeed this yeast is not naturally present in our gut. It is only because we eat foods that have that yeast on our food. But if we stopped eating any food that have that yeast, after a few days we would not have that yeast in our gut anymore. That's why, yes, they are naturally this yeast is naturally present in our gut, but only because it's in our food. It's not something that is autochtone from our gut, like from birth, let's say. Okay. Here they say, so this is part of a study. They say Saccharomyces cerevisiae might just be a transient yeast in the human gut, and it is a transient yeast. Transient, it means that it comes and goes. It doesn't stay and live and make colonies in our gut. Experiments have shown that when given orally, healthy people clear Saccharomyces cerevisiae from their intestines within 5 days. So we have a mycobiome. Myco means fungi. So we have a mycobiome made with fungi, and it's normal and natural, and any healthy human have different strains of yeast and fungi in their gut. So here in this study, they counted 267 distinct valid species of different fungi. Okay, and they say here it is dominated by Saccharomyces, Malassezia, and Candida strains. Species including Candida albicans, Tropicalis, blah, 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 so different types of Candida that are naturally in the gut, and they say in healthy individuals range from 30 to 60%. So it depends which study you look at. I remember several years ago I read it was more about 10%. So I guess it will depend on the people they studied, and it will depend on the diet that these people have. The more carbs in the diet, the more Candida and other yeast you will have in your gut. Cladosporium, along with Aspergillus and Penicillium, are a filamentous fungus or mold, and they are naturally in our gut in that form. Okay, so there are different types of fungi. they are in the form of yeast or in the form of filamentous fungus, and it's normal. So here again they say Saccharomyces cerevisiae is in the gut, presumably originate in foods. We would not consider Saccharomyces cerevisiae as an autochthonous gut organism, nor a true human commensal. And here they say that they found that Candida abundance was positively correlated with recent consumption of carbohydrates and negatively correlated with total saturated fatty acids. So that is very interesting. So it is something that is known now, that the more you eat carbohydrates, the more Candida strains you will have in your gut, because Candida love sugars. So the more sugars that you eat, the more Candida you will have. But something that most people don't know, and I didn't know until I read this study, is that the more saturated fatty acids you eat, the less Candida you will have in your gut. And actually, I always recommend people to eat animal saturated fats, because it's healthy for lots of different reasons that I talk about in my different videos. And also I have an article about fats. I will put the link of the article in the description box under this video. But if you have problems with Candida, if you have Candida overgrowth, number one, eat a diet low in carbohydrates, and number two, eat a diet high in saturated fatty acids. Okay, animal saturated fats. Okay. Recent consumption of short-chain fatty acids drove down the abundance of Aspergillus. So here's the same. If you have Aspergillus overgrowth in your gut, eat sources of short-chain fatty acids. And here they say that the composition of the gut microbiome is not particularly stable compared to the bacteria in the gut. So the types of bacteria and the amount of bacteria that you have in your gut, they will stay more or less always the same way. Whereas the type of fungi you have in your gut, they can vary a lot depending on your exposure to different fungi on your food and in your environment. Okay, what are the living conditions of Saccharomyces cerevisiae? So the best temperature for them to grow, for this type of yeast to grow, is 30 to 35 degrees Celsius. But the virulent strains grow from 0 Celsius to 45 Celsius, and they are viable until 58 degrees Celsius. Okay, they can also transform into pseudo-hyphae under nitrogen-limited conditions, and they can also form biofilms. So this is important to know, because this is what makes Saccharomyces cerevisiae virulent. Okay, that's what it makes Saccharomyces cerevisiae pathogenic. Okay, so here they say basically that when there's nitrogen limitation and a poor carbon source, so I'm not sure what I mean with that. I guess it's some types of carbon sources that are a stress for this yeast, and other types of carbon sources that, on the contrary, help them. But yeah, these things, these conditions can make Saccharomyces cerevisiae change into the pathogenic form. Here they say it has been proposed that both low nitrogen and a high level of glucose or a related sugar are required to trigger pH growth. pH is pseudo-hyphae. Okay, so the pseudo-hyphae form is the most virulent form. Okay, so and here they say when there's low nitrogen, so nitrogen is made from the consumption of meat, of proteins. So when your diet basically is low in proteins and high in sugar, that's what can trigger the virulent form of Saccharomyces cerevisiae. Is the same thing more or less with Candida albicans. I have lots of videos about Candida albicans. If you want more details about Candida, it's quite similar in many ways to Saccharomyces cerevisiae, but not always. Like here, for example, regarding the pH, Saccharomyces cerevisiae will grow the best between 2.75 to 5.2 pH, but some strains can live at pH 2. Okay, so the favorite pH of Saccharomyces cerevisiae is an acidic pH, and it grows better at an acidic pH than at a neutral or alkaline pH. And Saccharomyces cerevisiae stops growing at a pH of 8. Okay, so this is where it differs kind of with Candida albicans. Candida albicans is able to grow at neutral and alkaline pH. So, regarding salt, Saccharomyces cerevisiae can live in a concentration between 0 and 5% of salt, and above 2%, its growth is reduced. So when you make sauerkraut, for example, to make sauerkraut, you mix vegetables with salted water. And the salt in the water will limit the growth of some yeast and molds, and it will, on the contrary, benefit some other types of yeast and bacteria. So here, for example, if you put above 2% of salt in the mix for your sauerkraut, you won't have lots of Saccharomyces cerevisiae. Saccharomyces cerevisiae can tolerate up to 10% ethanol, some commercial hybrids up to 20%, as we said earlier when we talked about wine. They grow and they select and they hybridize Saccharomyces cerevisiae so it can withstand higher levels of ethanol. Saccharomyces cerevisiae, by producing ethanol, kills other microorganisms that could compete with it. Saccharomyces cerevisiae is tolerant to various metals and metalloids, and it is used in removal of heavy metals such as lead and cadmium from contaminated soils. And Saccharomyces cerevisiae is sensitive to chlorine treatment. Okay, Saccharomyces cerevisiae as a pathogen. So, Saccharomyces cerevisiae is considered as an opportunistic human pathogen of low virulence. In Europe, Saccharomyces cerevisiae has been upgraded from generally regarded as safe to biosafety level 1, indicating the ability to cause superficial or mild systemic infection. Okay, so for a long time, for many years, it was considered as a very safe yeast that would never cause issues, but they changed that several years ago. They realized that yes, it can be a pathogen. Among the reported invasive fungal pathogens in North America, Saccharomyces species infections accounted only for 0.35%, so that's not a lot, of invasive mycosis compared to 75% of infections caused by Candida, 12.3% caused by Aspergillus, and 4.5% caused by Cryptococcus. So again, Saccharomyces cerevisiae is not the most virulent type of yeast, Candida albicans. It can be much more dangerous. But here it says that often fungal infections are arbitrarily declared to be due to Candida because research is not thorough. For example, in the hospital, if a patient has an infection, they will send their tissues or their blood to the lab to define if the infection is fungal or bacterial. And if they find that it's a fungal infection, what they will do, usually they won't research more than that. They will say, okay, it's fungal, and if it's fungal, it must be Candida. They don't check if it really is Candida or if it is another type of yeast like Saccharomyces cerevisiae. So that's why this number 0.35%, maybe it is in reality higher, because they actually don't research it usually. So here, in one case, a patient was admitted to the hospital for hypotension, shortness of breath, and chest pain. The patient had a number of predisposing factors and was on a health diet. So listen to that. The health diet, according to that patient, was consisting of a large daily intake of vitamins and brewer's yeasts, okay, nutritional yeasts. Okay, so in my opinion, neither of these two things are part of the health diet. I have many videos about the dangers of synthetic vitamins, vitamin supplements. So I will put the link on the top right corner of this video if you want to go watch my videos about that subject. And here, because he was eating nutritional yeasts every day, he got an infection from that. Saccharomyces cerevisiae, that is the yeast in nutritional yeast, was isolated from the lungs, and the ingestion of baker's yeast was identified as the source of infection. The ingestion of brewer's yeast has previously been associated with fever. So this guy, he was eating nutritional yeast every day, and from his gut, the yeast traveled to his lung, and he got lung infection. In one study, mice immunocompromised by antibiotics were infected with food strains of Saccharomyces cerevisiae. So they took healthy mice in the lab. They killed their immune system by giving them antibiotics, and then they fed them with Saccharomyces cerevisiae, and they got an infection from that yeast. And the same happens to you, okay? When you take antibiotics, in many of my videos, I warn people about the dangers of antibiotics and chemical drugs in general, because when you take antibiotics, it shuts off your immune system, and then after you take this course of antibiotics, your body is open to any type of infection. Okay, so that's very dangerous. So what makes Saccharomyces cerevisiae a pathogen that can be virulent? So not all types of Saccharomyces cerevisiae strains are virulent. Some strains are more virulent than others. Okay, the ones that are the most virulent are the man-made Saccharomyces cerevisiae. The ones that are artificial, they are selected artificially, they are hybridized artificially, and they do that so they are more resistant to different types of temperatures, to different types of conditions, so that it's easier to use these modified yeasts to produce industrialized food and alcohols. Okay, because they will be more resistant, so they won't die easily. So yeah, they can put them in harsh environment and they will keep working and surviving. But when they do that, it makes them more virulent in our body, and they can become a pathogen much easier than the natural strains of Saccharomyces cerevisiae that are in nature. Okay, so what makes these artificial strains virulent is that they will resist high temperature up to 42 degrees Celsius. So let's say you have an infection from a natural strain of Saccharomyces cerevisiae. Your body will make a fever like 38, 39 degrees Celsius, and at these temperatures, the natural strains cannot survive. So your body can get rid of these strains like quite easily. But if it is an artificial strain, your body temperature won't be enough to kill it off. Okay, that's why these artificial strains are dangerous. These artificial strains, they also make different enzymes like proteinase and phospholipase that allow them to dig into the tissues of your body. Okay. They also have the ability to survive in the presence of hydrogen peroxide that is produced by macrophage to eliminate intruding organisms in the body. They also have the ability to transform into pseudohyphae in starvation situation. Okay, so these artificial strains, they are very resistant, and that's why they are dangerous. Your body will have a hard time getting rid of an infection caused by these artificial strains. Okay. But really, who is at risk? It's not everybody. If you have a good terrain, if you are very healthy, your body will know how to deal with that yeast. Okay, but if you have low immunity, if you are sick, if you have any type of chronic disease, then yes, you are susceptible to be infected by that yeast. So it will be people who have gastrointestinal diseases, cancer, AIDS, diabetes, broad spectrum antibiotic therapy, implementation of prosthetic devices or intravenous catheters, bone marrow or organ transplants, surgery or significant trauma, chronic kidney disease and diabetes mellitus, and in fragile people like newborns and elderly. Okay, so be careful if you know that you are in one of these situations. If you have a low immune system, it's really not a good idea to eat lots of foods, probiotics, or products that have these yeasts. And then here they say, of course, it depends on your terrain. It depends on your immune status. So what are the causes of infection? So basically, that's what we said before. If you are an immunocompromised individual and you ingest yeast tablets like nutritional yeast on a regular basis, if you eat bread made with that yeast, or if you associate with individuals who work in close contact with the yeast, then you could get an infection. like in this last part, for example, it's people who there are cases of women who are married to bakers and they get infections because of their husband that manipulate that yeast all day long. Okay. Here it says in people who have leaky gut, in vitro studies using human epithelial cells have shown that Saccharomyces cerevisiae does not affect the membrane integrity of the intestinal barrier, and a pre-existing breach would likely be required to initiate systemic infections via the gut. So the yeast doesn't cause leaky gut, but if you have leaky gut and you absorb that yeast, then it can travel from your leaky gut to your bloodstream and your organs. Okay, in the hospitals, most of infections caused by Saccharomyces cerevisiae come from the administration of Saccharomyces Boulardii probiotics. Yeah, and it is capable of forming biofilms. Okay. In people with Crohn's disease, they found lots of antibodies. They found lots of Saccharomyces cerevisiae antibodies, meaning that people with Crohn's disease are more susceptible to infections by this yeast, or it could mean that their Crohn's disease can be caused or worsened by this yeast much more than any other people who have other type of gut diseases. For example, here it says, according to a study, Saccharomyces cerevisiae antibodies are found in 57% of Crohn's disease patients, in 19% of ulcerative colitis patients, in 30% of other types of colitis patients, and in 8% of healthy subjects. In one study, yeast caused a threefold increase in lymphocyte proliferation in Crohn's patients relative to normal controls. Anti-Saccharomyces cerevisiae antibodies was associated with proximal, that is gastroduodenal and small bowel involvement, rather than purely colonic disease. So again, people who have the most issues with that yeast are people who have diseases of the stomach and the small intestine, more than the people who have diseases in their colon. So, what infections are commonly caused by Saccharomyces cerevisiae? It can cause vaginal infection. And as I said here, it says, in several cases, the women affected were in relationship with bakers or pizza makers. In others, they had been contaminated by the yeast they used in cooking at home. Saccharomyces cerevisiae can cause invasive infection, so infection of the blood or the organs. That can be fatal in 30% of cases. And as I said earlier, they are much rarer than those caused by Candida albicans. So again, Saccharomyces cerevisiae is not the worst type of yeast, but it can cause issues. It can cause lung infections, and it can cause nosocomial infections due to yeast. Saccharomyces cerevisiae causes up to more than 3% of nosocomial infections due to yeasts. And caused mainly by intravenous catheters and antibiotics. So the special case of Saccharomyces boulardii. So Saccharomyces boulardii is a strain of Saccharomyces cerevisiae. So it's Saccharomyces cerevisiae var. Boulardii. Okay, and it is used as a probiotics. Here in France, we have it under this brand, but all over the world, if you are in the US, yes, you can find Saccharomyces boulardii as a probiotic. And yes, it can be a probiotic for many different reasons, because it's very resistant, so it will survive passage to the target organ, that is the colon. It will survive gastric acid, bile salts, enzymes. It is resistant to antibiotics because, of course, antibiotics, they kill bacteria but not yeast, and Saccharomyces boulardii is a yeast. It has antimicrobial activity against foodborne pathogens like E. coli, Salmonella, C. difficile. It activates both innate and adaptive immunity. It improves the re-establishment of normal gut flora among patients with chronic idiopathic diarrhea, and it facilitates the growth of bifidobacterial and lactic acid bacteria while inhibiting pathogens. So on the paper, it looks great, but this yeast can cause infections. Saccharomyces boulardii causes 40% of the Saccharomyces cerevisiae infection cases. So what are the allopathic treatments if you have a Saccharomyces cerevisiae infection? So they will give you antifungal drugs like amphotericin B, fluconazole, or clitromazole. There are other type of chemical antifungal that they can use, but they all have bad side effects. Like this one has adverse effects on the renal system that can be really bad. They can create resistance and so on. So personally, I don't recommend using these chemical drugs. I much prefer the natural remedies, because I see all the time people who took chemical antifungal drugs, and it works in the moment when they take the drugs, but then a few weeks or few months later the infection comes back. That's how it works usually with chemical drugs. Whereas when you take natural remedies, you have very low chances of relapse. And also they can use boric acid, particularly as a suppository that they use for women with vulvovaginitis. So personally, I don't have much experience with boric acid. I know in the US, people are crazy about that. Naturopaths use boric acid a lot. Here in France, and I guess maybe in Europe, but at least in France, we don't really use it. So I don't know this product much. I'm not even sure if it's easy to get here in France, so that's why I don't know this product really. But I know that in the US I've read many articles and testimonies of people who use boric acid, and it looks great. So I don't know, maybe it's good, but I don't know. I prefer more natural stuff. So it's supposed to be natural, but I mean, I prefer other stuff that sounds more natural to me and that I'm more used to, like here, like this. So what I would recommend to someone who has Saccharomyces cerevisiae infection, I would recommend a diet low in sugar and no processed foods. Stop eating processed foods. It's important. I would recommend a diet rich in saturated animal fat, because as we saw earlier in this video, it can lower the populations of yeast in your gut. I would avoid foods rich in Saccharomyces cerevisiae. I have talked about these foods in the beginning of this video. I would recommend to that person who has an infection, I would recommend antifungal herbs in the form of essential oils or pills or tinctures. But yeah, whatever the form, they are very efficient antifungal herbs that will help. I have many videos about that on my channel. In these videos, I talk about these remedies for candida, but it will be the same thing if you are infected with Saccharomyces cerevisiae. I would recommend biofilm breakers because, as we saw in this video, Saccharomyces cerevisiae can make biofilms. And I would recommend taking probiotics, but I would, of course, not recommend probiotics made from yeast, but made from bacteria like Lactobacillus and Bifidobacterium. And even better, if you can tolerate probiotic foods like kefir and yogurt and sauerkraut, that would be a great way to repopulate your gut with the proper strains of yeast and bacteria. And generally, these are my general recommendations for anyone, even for people who don't have an infection from Saccharomyces cerevisiae. But to anyone, I always recommend to not take Saccharomyces Boulardii probiotics alone. If you want to take probiotics, it's great, but I would not recommend Saccharomyces Boulardii alone. Always take it together with regular probiotics like Lactobacillus and Bifidobacterium. Don't take Saccharomyces cerevisiae probiotics. Don't take nutritional yeast. Don't eat nutritional yeast if your gut microbiome is not healthy, because it can cause an infection from that yeast. Don't eat a processed diet. Choose sourdough bread and pastries instead of regular breads and pastries. So that's, of course, that's if you eat bread and pastries. If you don't, that's even better. If you drink alcohol, choose alcohols made with wild yeast, as I explained in the beginning of this video. Okay, that's it for today. I hope you learned something today, and I hope it helped. If you need any help, if you have any type of gut disease or any type of problem with your digestive system, I have a course on how to heal your gut naturally. The link is under the video in the description box. I see you in the next video. Bye bye.